Today's topic, we're going to continue with reflections, but instead of going over an x-axis or a y-axis, we're going to go over a given line. You can use the date of May 21st. Your note packet should have 3 pages. Before we start reflecting, I'm going to review some graphing of horizontal and vertical lines. There's not a spot for this on your notes, but I just wanted to refresh your memory because we're going to use this topic today. In algebra, you probably learned that when you graph a horizontal line, it has a special equation. So what we see in the equation is y equals 3. It has a y-intercept, but not an x-intercept. When you graph this, that means that the line goes across the y-axis at positive 3. So it's going to look like this. And we want to make sure we label it. So if I were to try another horizontal line, y equals -2, again, it's going to go across the y-axis at -2, and we would label it. If we reflect over a vertical line, this also has a special equation. It has an x-intercept and nothing else. So the equation is going to start with x equals. So in this equation, x equals -4. This is a vertical line crossing the x-axis at -4. And we can put another one at x equals 5. So it's a vertical line at 5, and we label. So when we graph today, we're going to go over different types of lines. They might be vertical, they might be horizontal, but they won't be the axes. So one of our special reflections is graphing over the line y equals x. Now this line is a little bit different. It has a slope of +1 and an intercept of 0. So what that tells me is when I have a slope of 1, I also have a y value of 1. When x is 2, I have a y value of 2, and so on. And it works in the positive quadrants as well as and the negative quadrants. So we're going to abbreviate reflection with a lowercase r, and in subscript, we're giving you the equation of the line that you're reflecting over. So this is our shorthand instruction. We're going to reflect triangle ABC over the line y equals x, and that will create triangle A prime, B prime, C prime. If we look at the location of A on the original figure, it's at -4, 2, and then on A prime, it's at 2, -4. For B, we were at -3, -1, and now for B prime, we're at -1, -3. So hopefully you're seeing that the coordinates will switch places. So when you reflect in the line y equals x, we'll take our generic point P located somewhere in the coordinate plane. It will map itself to P prime, and we're going to switch the location of x and y. Now this is our third rule, and if you're starting to get overwhelmed with rules, counting will work. Because my line of reflection is diagonal, you must also count on a diagonal. So for example, B, on a diagonal, I have 1 box to get to the line of reflection. I'm going to go 1 more box to locate B prime. It works with C and A. For C, it's 1.5 blocks. So for C prime, it's going to be 1.5 blocks. So you can count, but if the line of reflection is on a diagonal, so is the counting procedure. Let's try example number 1. I'm going to first plot my figure, my pre-image. So we have triangle HMO. I've labeled all the vertices. Make sure you're using a straight edge. I did draw in the line of reflection y equals x. Because the rule is so simple, I'm going to remove that, and I'm just going to use the rule to come up with my new ordered pairs. But I just wanted to show you where it was so that if you wanted to count, you could. The rule says I switch their spots. So for H prime, it's now 1, -3. We'll do the same for M prime. And we don't want to forget to write our rule above the mapping. Don't forget to do this on your homework so that you don't lose any points on your weekly quiz grade. M will now be 4, 0. And O prime is at 0, 2. So now that I know the locations, I can go ahead and graph triangle H prime, M prime, O prime. And there it is. You'll also notice I did put the line of reflection back in. The original figure in red was laying across the line of reflection. So that means that the image does as well, and they will always overlap in that case. In example 2, I'm going to need you to change your notes a little bit. For the example, we're going to reflect in the line y equals -1, not y equals -x. So again, we're starting with triangle HMO. It's the same triangle as the last time. But I'm also going to have you start by graphing the line of reflection. So we're drawing a horizontal line at y equals -1. It will be really helpful if you draw this in with your straight edge, but use a bright color. So draw it in with red pen or pink pen, something that stands out, because we're so used to going over the axis that your mind will play tricks on you. Now, when you reflect over a given line like this, it doesn't work the same. We don't have a nice rule that helps us. So what I'm going to do is plot triangle HMO. My line of reflection is horizontal. So what I'm going to do is take each point. H is 2 blocks above the line of reflection. I'm going to count 2 blocks below the line of reflection. So the location of H prime will be at -3, -3. So I'm going to go ahead and record that. We're going to count for each of these points because this is a special case. Point M, it is 5 blocks above the line of reflection. We're going to count down 5 blocks. So the location of M prime is going to be at 0, -6. And for O, we are 1 block above the line. So we're going to move 1 block away. O prime should be located here at 2, -2. So there is no fancy rule when you're graphing over a vertical or horizontal line that's not one of the axes. And I'm going to include my mapping rule right above the arrows. And then I'm going to draw my image. You'll notice it's the same shape and the same size, just like we've seen in the past. We can also reflect our point or segment or figure through the origin. Again, we're going to abbreviate R for reflection, lowercase, and then we put an O in subscript to represent the origin. And the shorthand notation works the same way. We're going to reflect triangle ABC through the origin to produce its image. If you look at the location of A at 1, 4, we're going to go through the origin and then the same distance away to A prime. It ended up at -1, -4. For B, we were at 1, 2. And now we're at -1, -2. And I imagine that you're establishing the idea that we're going to negate the x and negate the y. So to use the rule, we're going to take our generic point P located somewhere in the coordinate plane. It will map itself to P prime by negating x and negating y. Now, if x or y was already negative and you negate that, it will turn into a positive. Counting also works because now this is our 4th rule. When you count, you must count to the origin. So for A, I would have to drop 4 blocks and run 1 block to the left to get to the origin. And I'm going to follow that same pattern away. Drop 4 blocks down and 1 to the left. Each point on the figure will have its own pattern to get to the origin, and then we'll use that pattern to move away from the origin. So for B, it's 2 blocks down and 1 block left, 2 blocks down and 1 block left. And all the points will travel in their own slope pattern. For this example, we have triangle XYZ. We're going to reflect through the origin to create the prime. I'm going to graph triangle XYZ. I'm also going to highlight the origin just so that it stands out and I know that I'm going through that point and then I'm moving away from it. So let me start with X. In order to find its new location, I have to rise 2 blocks and go 1 to the left. So I'm going to follow that pattern, rise 2 blocks, 1 to the left. This location is -1, +2. So that's where X prime is located. For Y prime, we're going to actually drop a block and run 2 to the left, drop a block, 2 to the left, -2, -1. And for Z, we have to rise 4 and go 4 to the left, If I do that again, 4 up, 4 to the left, I'm at -4, +4. And we don't want to forget our rule, reflect through the origin. And now I'm going to go ahead and graph those points. Again, our figure is the same shape and the same size. What's a little different here is now it's also looking as though it's been turned a little bit. In our fourth example, I'm going to ask you to make a few changes on your notes. We're given a triangle MLN. We're going to find the value of triangle X double prime, Y double prime, and Z double prime. So this is a little different than what we're used to. We're not graphing in this case. Sometimes graphing is not required. So we're going to first reflect through the origin. This is where you need to make a change in your notes. It did ask you to have something with a D, which is dilate. I'm going to have you cross that off and put reflect through the origin. The second rule will be okay, and we'll use it as is. But I am going to have you cross off the third rule, the capital T. That's a translation, and we haven't covered that yet. The idea is when you come up with your first prime, that you just keep building on. We don't want to start over with the second bullet point. You just want to keep going. So when we do this without a graph, of course, we start with our 3 original points, and we're going to do a complete mapping. So we're going to put the rule, reflect through the origin, and we said the rule was to negate them. So I did bring all of the points up. I've negated X and negated Y. Y does not take a negative in front of it. It's neutral. So negate X and negate Y. Now, to do the second part, we're going to reflect in the X-axis. Remember what the rule says. We're going to take the first prime image and reflect it to create the double prime image. So what I'm going to do is put my rule, reflect in the X-axis, and my arrows, and I'm going to build on. The rule for the X-axis says X stays the same, but Y becomes its opposite. So all 3 points are just going to pop up. X stayed the same on all 3. Y changed, except 2 of the points are actually invariant because they're on the line of reflection. So one of the problems on your homework tonight is similar to this type of example. I just want you to make sure you keep building on and that you don't start over. This is your homework for tonight. It's 2 pages. Make sure you do a complete mapping for 13 through 16 where you start with your original points and then you show the mapping arrows with the rule and then the new location. If you have any problems with this assignment, please make sure you get in touch with me. Remember, I'm doing a weekly grade and I'm spot checking your work. Have a great day.